Hello guys, this video I'm going to explain this QD brute force exercise, which I think is a good start for brute force paradigm of algorithms. So we are conscious that to solve an algorithm, okay, we have various paradigms, all right, right. So I'm going to start by showing you the first one, which is the easiest, which is brute force, all right. So this is one first brute force exercise so you can better understand. Brute force basically means to try all solutions. Like try all, okay? Solve it. It doesn't matter the time. Time does not matter, okay? It is usually well used if we want to solve a problem to make sure that it has a solution at least, and then we can first do brute force. Okay, imagine we have an algorithm, right? So we can do brute force first, and then after that we can apply another paradigm, such as, I don't know, such as dynamic programming, all right, or divide and conquer. Okay, so basically this is the gateway of paradigms. So we're going to start with this which statement, right? So we have given an array of integer nums, right? Find the contiguous subarray containing at least one number, which has the largest sum, and return its sum. Okay, so basically we have to make sure that we understand the statement. We're given an array of integers, right? So we cannot have -1 or -10. We're only working with positive integers such as 1, 2, 5, 100, and we are not working with decimals, so we don't have 5.5 or 7.8. We don't have that, all right? So we only have integer inside the array. After that, we are asked to output a contiguous subarray. So basically, imagine we have this array 1, 8, and 5, right? So this array has 1, 2, 3, 4, 5, 6, and 7 if you count no. 7 and 8. So it has 8 possible subarrays. Okay, possible subarrays. So so basically, I think you could determine this using 2 and then n, and n being the size of the array. So in this case, in being 3, all right? So 2 times 2 is 4, and then 4 times 2 is 8. So we know that we have 8 possible arrays, right? So what is the first one? The first one we have 1, and then we have 1 and 8, and then we could possibly have 1, 8, and 5. And then we start with the 8. We have 8, and then we have 8 and 5, and then we have 5. So then we have 1, 2, 3, 4, 5, 6. 6. We still need 2 more. So the 7th would be let me see. So the 7th one would be null, all right? So it would be null, and then all right, so 8, 8, 5, 1, 8, 5, 1, 8, 5, 1, 8, and then we have 1, 5. Yeah, I forgot to write that down. We have basically 1, 5, 1, 8, 5, right? So yeah, that's it. So we have 1, 2, 3, 4, 5, 6, 7, 8, right? We have 8 possible subarrays, but not all of them are contiguous, right? Not all of them are contiguous. We need contiguous, okay? So for contiguously, we that means that we need neighbors, okay? We need adjacent or yeah, basically that we need adjacent or neighbors subarrays such as 1, 8 or 1, 8, 5 or 8, 5 we cannot have 1 5. That's incorrect because those are not neighbors, right? Those are not neighbors. We need to have a contiguous array. So we discard, all right, we discard this. So this cannot be, and this also because we are not looking for, we are asked to be at least one number. So at least this, all right? So with that, we are left with 6 subarrays which are contiguous. And then we need which of these subarrays has the largest sum, all right? And then return its sum. Which one has the largest sum? So we can do this here easily just by reading the numbers. So 1A and then 1A5. So I believe 1A5 is the biggest sum. So basically all of the array. So we will have 14 if I'm not wrong. Yeah, 14 will be the return. But imagine that we will have also we will have negative, right? Negative numbers. Okay, imagine if we will have negative numbers. Okay, for example, we will have here also -1 or -10, right? And then we have more and more numbers, so the n size is bigger, all right? So in that case, we need at least some kind of algorithm to solve this, all right? And we can use brute force. So brute force here is applied because we are going to try every possible subarray that are at least, all right, that are at least contiguous, all right? So I've come up with this algorithm. So this algorithm basically says that you have a total. You have first, let's declare the name of the function. So for example, I will have sub contiguous array. So that's the name, and then we're going to, just for educational purposes, we're going to utilize pseudocode, all right? Not Java, no C, not Python, pseudocode. So A would be the array itself, and N would be the size of the array, all right? And then what we can do. So this thing is going to work with 2-4 basically. Why is going to work with 2-4? Because as you can see, we are constantly doing every instance of each number. So we compare each number to the next and then to the next. So and then after that, we're going to compare this number to the next and then to the next. So as you can see, we're going to be needing here 2 4s. All right. So the first for loop is going to be I equals 1, all right, to n, and then the second for is going to be j equals I, all right, then to n. So what we want here is basically think of the first case. Okay, let's see if we start with -10. All right, we first have this subarray. We contains at least one number, and we have to save it somewhere. All right, so we have to save the result, and what we are going to do is we're going to basically sum it. Okay, sum it with the maximum variable, and then we're going to do a of j. Okay, and then if that maximum, okay, is bigger than the total, here will be maximum, and here we're going to do something like sum. All right, sum. If the sum is bigger than the maximum number, or the maximum sum, so that means that sum is the maximum now. So we're going to do max equals sum, right? All right, and then of course we need to declare this sum somewhere. All right, so for now I'm going to declare outside the two loops sum equals minus infinite. All right. So this minus infinite, it could be 0, okay, but I prefer doing it with minus infinite. I think it looks cool. So basically what we're doing here is we looping first with minus 10, and then we are doing minus 10 plus 1, all right? That's what we are doing here. Why? Because this one here, all right, this j is the next index, all right? So so basically first we start with index 1, of course. J first I is 1 and then j is 1, all right? So those indexes point to the minus 10, all right? But we need to start not summing itself, but summing to the neighbor or to the contiguous item. So we're going to take this j to index 2 so that we can sum minus 10 plus 1, all right? So that is going to be minus 9, and that's what we, all right, that's what we save here, all right? So actually here is wrong. We need to set that this is the maximum, all right? And then we need to set sum somewhere, right? So let's go through this again. So we have our first loop, okay, from 1 to the size of the array, and then we start with I1, all right, and then with j1. That's what happened here and here, all right? So then after that, what we're going to do is take this value here, a1. Basically a1 is minus 10, all right? And then that minus 10 is going to be sum with the sum variable, all right? With the sum variable. The sum variable right now is 0, all right? So the sum is going to be minus 10. And then what we do is compare minus 10 with the maximum. Minus 10 is bigger than minus infinite. Yeah, of course it is. So the maximum, the new maximum is going to be minus 10, all right? And then we loop inside this for, not the outside for, inside this for. Because why we need that? Because we are comparing minus 10 first with all of its neighbor, all right? So we continue with minus 10 here, but now, okay, now j is different. Now j is 2. So as j is 2, so aj is not longer going to be minus 10. Why? Because j2 means that it's going to be 1, all right? So what we're going to do is add that 1 to the sum, but we know that this sum, all right, was minus 10 before. So basically we are going to do minus 10 plus 1, which is going to end up with minus 9. So now minus 9, we compare minus 9 with minus 10. And in fact, yes, it is bigger. So it's not anymore minus 10, the maximum amount, but minus 9. Okay, so we're going to do that with all of the neighbors of minus 10. So minus 1 plus minus 1 alone, and then minus 1 plus 1, and then minus 1 plus 1 plus 8, and then minus 1 plus 1 plus 8 plus 5, and so on. So we're going to select from this iteration which one is the maximum, right? And then after we are done with minus 10, we're going to start with 1. So 1 first, and then 1 with a, and then 1 with a with 5, and from this we're going to select the maximum, all right? And this maximum is probably going to be bigger than this one, so this is going to be the new maximum. And so until we loop all of the array. So that's why brute force, you know, we could have already let's say we could have already solved the problem, but we have to continue doing all of these, because all of these iterations. So that's why with brute force you could take a long time, but it solves the problem, and that's what matters. So here's the pseudocode, and hopefully you guys understand. Thank you for watching. See you next time.